Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 240, largest color value in a directed graph. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So this problem has a lot of different components. I urge you to kind of practice it. The components, and I'll let you know what the components are, obviously. But I definitely struggled with this one because I was just a little bit sloppy. I think, to be honest, you look at the times and you see people doing like 5-6 minutes, and I'm like, yeah, I probably could have done it. Maybe not in 5-6 minutes because these people are really good, but maybe like 10 minutes. But instead, I took 25 minutes with a wrong answer because I was just sloppy and on a easy part. And the easy part, for example, is that this is a directed graph. You have to first detect whether there's a cycle, and this is something that most people know, and I should have known better, but I spent way too long here, and I kind of did an incorrect implementation. I mean, I didn't get the wrong answer from that, but yeah, but this is, so basically, first, I set up an edge list. I actually don't end up using but yeah, after this edge list, this is just really basic cycle detection. I did it with the 3-color way. There's another way of doing it, but I recommend reading up on the literature. This is O of N, or O of V plus Y, where V is the number of vertices and Y is the number of edges. So this is linear in the size of the input. And then the second part is something that I just did it I had a really weird assumption about dynamic programming during the problem, but I think I struggled with something that was, or like I summed up things in a different way. Basically, I sum up all the edges instead of taking the max of all the edges, so I was getting a funky answer, but it somehow passed the examples, so I was a little bit sad going back. Basically, if I had a 0-2 and then another edge that's 0-3, I double count stuff because I sum instead of getting the max, which is not great. But then the way that I decompose it, and you could, of course, watch me solve it live during the contest after this, the way that I solve it was with dynamic programming. The key thing to note is that, for each input, because now that we proved that it's a DAG because it doesn't contain any cycle, that means that for each node and for each color, we can return the same answer. And because of that, there's going to be at most 26 times n, because there are only 26 colors. So that's going to be fast enough because n is 10 to the 5th. So this is going to be linear times 26, or if you want to do U as this number of colors, then it's U times N. And that's pretty much it. This is a very straightforward dynamic programming kind of once you get there, because once it's the same color, then you just count the number of okay, so this is actually a dynamic program, where return, because I got depth research, but it's not quite true, but return the max number, the path containing color starting at creating the most color. Yeah, so that's basically the idea behind this recursion. So first you start with count 0. If it is 0 to the current, you increment it because that's how you do the current. Otherwise, well, I mean, in either case, you basically take the max of the recursion of the new color that on the new edge that you go to. So basically, you just do one on every edge, and then the color. Yeah. So basically, now this is going to be O of V times Y, or V plus Y, sorry, times 26. Because so the idea here on doing the analysis is that for each node and vertex, you are going to make one call for each color. And I know that this for loop is a little bit scary, but because you amortize all the edge out such that every edge to a color is going to, every edge is only going to be activated once, because it cannot happen a second time, because it requires this to be called a second time, which we cache. So yeah, so this is going to be this is times u, where u is the size of the, where u is number of alphabets, or 26. So yeah, so this is linear-ish, and for this case, it's going to be fast enough. We do a micro optimization where in this case we only start out with the colors because it doesn't make sense to start out with another color. So yeah, but in the worst case, it will still be this thing, and yeah. In terms of space, we do linear space here with the coloring, and we do linear space in terms of O of ye. So the number of edge space to rewrite the edge list. We do number of re space for the colors, so that's going to be O of re, and the stack space is going to be O of re plus ye for both Psycho and this dynamic programming. So everything together in space is going to be re plus ye. That's all I have for this problem. It took me way too long, even though each of the components are pretty easy for Q4 anyway. It's not an easy problem, but for Q4 I think it's easy. And like I said, people have done it in like 5 to 6 minutes. I probably should have done it in 10 to 12 minutes maybe. If you watch me solve it live, you see me just like struggling on the silly part, and then I got a wrong answer because I just implemented this in a weird, like my recurrence was just wrong, and then after I was like, oh wait, I'm not supposed to sum, I'm supposed to max, and I'm like, oh wait, this recurrence doesn't make sense for max, and then I'm like, oh, actually you could pull out a dimension and use color, and then everything fell together. Yeah, that's all I have for this problem. Let me know how you did, how you did, and yeah, just let me know everything. Hit the like button, hit the subscribe button, join me on Discord. Oh, and you can actually watch me try to solve it live during the contest next. Okay. Turned out to be okay. A little bit slow today, but it is what it is. Okay, largest color value in the direct graph. 0 to n minus 1. Man, 36 people got this already, so I'm really slow today. A routed path is the number of nodes that are colored the most frequently along the path. What are these? Oh, these are the colors. 0, 2, 3, 4 contains 3A. The cycle is a little bit awkward. Okay, maybe not. It's just any cycle. So it's gonna be depth first search probably, but. So if there's this should be pretty straightforward. Basically, okay. Hold on, I want to do the cycle. The cycle part is easy. Okay, let's just do. Which one is N and Oh, I guess it has to be. Which one is N and M? Oh, edges length. The colors are less than N, so okay. Are we given N? Man, I should know this part better. So the only way that it is not is that if there's a tree, so... Yeah, okay. -1, I think. Okay. Oops. Oh, whoops. Okay. Otherwise, it's just depth for search. I guess this could be n squared, right? No, edges is 10 to the 5th. Does that matter? If it's a tag, man, my graph is very bad. Do I need to memorize? Do I need to memorize? Colors are 26. 26 times 10 to the 5. It's a little bit sketch to memorize everything. I don't memorize. I should know this better. What is the worst case graph? do I need to memorize? Poop. It's kind of expensive to memorize. This is also wrong, I think. Why am I so bad? Yeah, I need to memorize. Does this need to be? My computer is being slow. I'm gonna do it with colors. Right. Let's see. Why did I? Oh yeah, that's what I tried to do here, but I am being dumb. My computer. Need a new computer. That's not true. This is bad actually, cause yeah, I think wow, I'm really bad today. So because this could have a thing, but there's a cycle elsewhere. So I am actually pretty bad about this one. This is actually really wrong. I should have named it color by now. think at this point I should be able to cache. So maybe I should have done it that way. Okay, and then now we have to do a different search. Let's just do. There's no cycle, so this should be good, but it's not. Is it good enough though? Oh man, my math is so bad. What is a map to? Of course, pay to win. Okay, that looks okay. And now to do this part. Oops. Oh yeah. That's not good. It does do stuff. Why does it return 0? Oh, what am I doing? This is right, but maybe too slow. YOLO. Ooh, wrong answer. That's actually not what I would have expected. That's not great. Expected 3. Why is there 10 in there? From 0, 0, 1. Am I doing something bad with my references? I don't think I'm reusing references, right? I mean, this is new, but I create a new one every time. Why? Why are you so bad? 0 and 1 doesn't make sense, so this is just really wrong. Zero goes to 10. Why? Did I mess up? Oh, I reuse re like in poop. 0 goes to 2? Do I have a 0 goes to... Oh, there is a 0 goes to 2. I'm just blind. Okay, 2 has all these beautiful things. Oh, I know. Because I'm double counting. Because I'm summing up all the things. I see. Oh, wow. Because okay, I know where I'm going wrong, but how do I fix it? You could cache it on color, but is that messy? Maybe not. Maybe that's the way to go, to be honest. Okay, fine. Let's go. Colors. I think this is easier to do than I should have maybe done it. Oh man, that was a... Okay. I don't know if this is too slow, to be honest. If color is equal to... Okay, so that looks good. 3, -1, 3. I don't know if this is going to time out, but that looks good at least. Maybe. Okay. That was silly. I misunderstood. Or I didn't. This would have been so much easier to implement. I don't know that I misunderstood the. I understood the prompt correctly. I just had a wrong assumption about it over. Yeah. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this prompt, its explanation, and all that good stuff. I did okay, but I don't know. Anyway, I will see you later. Stay good, stay healthy, to good mental health. Bye bye.